Welcome everyone. We are discussing conditional probability. Today, I will prove a theorem of total probability. So, what is theorem of total probability? Let E1, E2, E3 are three mutually exclusive and exhaustive events associated with a random experiment. Let A is any event which occurs with E1, E2, E3. Then PA equals to PE1 into PA by E1, PE2 into PA by E2, PE3 into PA by E3. So this is conditional probability. So there are two terms, exclusive. So try to make difference. So look, suppose this is A and this is B. So here A and B are, this is sample space S. A and B are exclusive. A intersection B equals to phi. Now what is exclusive and exhaustive? You look, suppose this is E1, this is E2, this is E3. So there is no common part. So E1, E2, E3 are exclusive. Here E1 union E2 union E3 equals to S, sample space, universal set. In this case, events are said to be, this is exclusive and exhaustive. There is no common part. Exclusive and exhaustive E1 union E2 union E3 equals to S. You know, for mutually exclusive and exhaustive event, PE1 plus PE2 plus PE3 equals to 1. But if it is not exhaustive, then PE1 union E2 equals to PE1 plus E2. So this is basic concept. So we prove the theorem for two events E1, E2, E3. Then you can prove it for 4, 5 up to any finite number of events. So this is our universal set, sample space. This is E1, this is E2, this one is E3. And A is any event which occurs with E1, E2, E3. Then this part is A intersection E1, common. This is A intersection E2. This is A intersection E3. A intersection E3. This one. So from figure, look, A is equals to E1 union E2 union E3, exhaustive. Now look from figure, A equals to A intersection E1, this set, plus, that is union, A intersection E2, union, A intersection E3. This set plus this set plus this set is A. Now look, these sets, this and this, A intersection E3, A intersection E2, A intersection E3. They are exclusive. So, exclusive event. So, if we take probability, we get plus. PA equals to PA intersection E1, PA intersection E2, plus P A intersection E3. P A intersection E3. So this one is equal to P E1 into P A by E1. Why? Look, P A by E1 equals to, from conditional probability, A intersection E1 by P E1. So what is P A intersection E1? P E1 into P A by E1. Similarly, this is P E2 into P A by E2. And third one is P E3 into P A by E3. So this is proof. PA equals to this. Now it is for 3 event. For 4 event, it is P4 into PA by E4. So it is true for any finite number of event. Now you can also prove it. Look, A equals to A intersection S. Now what is A? A is equals to E1 union E2 union E3. So using distributive law, this is A intersection E1 union A intersection E2 union A intersection E3. So this is from figure, or here using distributive law. Then same, this one and this one are exclusive. So PA equals to this. Then use formula of conditional probability. So PA equals to PE1. So you can write it in this summation form also. PEI, PA by EI. So I equals to 1 to 3. For event, 4 event, I equals to 1 to 4. So why it is called total probability? It will be discussed with the help of an problem, with the help of an example. So this is theorem of total probability. Most important theorem and most important problems are most important for board exam, not the theorem. Proof of theorem is not necessary. Now application. Now we consider problem number 1. A bag contains 3 white, 2 black balls. 3 white, 2 black balls. Another bag contains, second bag, 2 white, 4 black balls. One bag is chosen at random and a ball is drawn. Find the probability that ball drawn is white. Ball drawn is white. So there are 2 bags. So 2 event you have to define. E1. One bag is selected. One bag is selected at random. E1 that event that bag 1 is chosen. E2 bag 2 is chosen. So there are 2 bags. So PE1 equals to PE2. So half. 2 bags. So they are equally probable. Out of 2, 1. This is 1 by 2. 2 bags. So PE1, PE2 we are getting. Now what is our first observation? PE1 plus PE2 must be 1. So it is our first observation. Then we have to define an event A. So and a ball drawn is drawn. Find the probability that ball drawn is white. So A. So for white you write W equals to event that ball drawn from selected bag is white. Ball drawn from selected bag is white. So now white ball from bag 1 be W by E1. So look, W by E1, white ball from bag 1. So how many white ball? 3. So 3C1 by total 5C1. So now W by E2, white ball from bag 2. So how many white ball? 2. And this is 6. 2 by 6. Now find the probability that ball drawn is white. So probability of white ball. So you must state the formula PE1, P W by E1, PE2, PW by E2. For board exam, you must write this formula. This is half marks. Half marks is allotted for this. Now, put value of PE1. This is half into 3 by 5. Half into 2 by 6. So, half common. 3 by 5 plus 1 by 3. 3 by 5. So, half common. 3 by 5 plus 1 by 3. 2 by 6, this is 1 by 3. So, half into 15 LCM. So, 9 plus 5. This is 9 plus 5, 14. So, 7 by 15. 7 by 15. So, PW, probability of white ball. So, listen, white ball, it may be from bag 1. And this is probability for white ball from bag 2. This is probability of white ball from bag 1. This is probability of white ball from bag 2. We are adding these two. That is why it is called total probability. White ball, this is chance of white ball from bag 1 and this is chance of white ball from bag 2. So we are adding it. That is why it is called total probability. Now, this is the simplest one. Now, problem number 2. Exactly same. There are 3 bags. A bag is selected at random and 2 balls are drawn. What is the probability that ball drawn is white and red? So, here there are 3 bags. Exactly same. So, E1, event of selecting bag 1. E2, bag 2. E3. For board problem, you must state this. So, how many bags? 3. So, you have to select 1. 1 by 3 equals to PE2 equals to PE3. So, as of earlier, now look, you have to define an event A. So, what is A? Probability that ball drawn is white and red. A equals to event that ball drawn from selected bag is white. Selected bag is white and red. Selected bag is white and red. So P A by E1. So E1 total ball is 5, 6. So you have to take 2. 6C2. And how many white ball? 1. 1 C1, and means into. And red ball. How many red ball? 3. So 3 C1. So this is 3 by 62. This is 15. This is 15. Now PA by E2, 6C2. Now 4C2, sorry, this is 4C2. How many balls? 4. So this is 2C1. Out of 2 you can, and this is 1C1. So 2 by 2C1 is 2, 1C1, 4C2 is 6. So this is 1 by 3. Now PA by E3, probability of 1 white and 1 red from bag 3. So 9, 3, 12. This is 12C2, 4C1. Out of 4 white, you can take 1, and this is 3C1. So 4 into 3, 12. 12C2. So 12 into 11 by 2. So this is 66. So 4 by. This is 1 by. It is divisible by. This is 22. 22, 4 by 22. So this is 2 by 11. So divisible by 6. 2 by 11. Now we have to find PA. So PA equals to, you must write the formula PE1, PA by E1. So probability of A from bag 1. Probability of A from bag 2, A by E2, plus probability of A from bag 3. So this is our formula. Put the values and we get PA. So this one is very, very simple. So why it is called total probability of getting A from bag 1, this is 2, this is 3. We are adding it. That is why it is called total probability. Now we consider another type of problem. So there are 2 bags, 5 white, 6 black. This is bag 1. And bag 2, look, 4 white, 3 black balls. A ball is transferred from bag 1 to bag 2. Then a ball is drawn from bag 2. Find the probability that ball drawn from second bag is black. So what is the difference? Try to understand from previous problem. In previous problem, it is given that one bag is selected and a ball is drawn. But here, what is E1? E1 is you are transferring one ball from bag 1 to bag 2. It may be white or it may be black. So you are not selecting bag, you are transferring ball. So ball may be white or may be black. So E1 equals to event of transferring white ball from 1 to 2, and E2 event of transferring black ball from 1 to 2. So obviously PE1. So how many white balls? 5 white balls. So 5 by 11. PE2. So this is 6 by 11. How many black balls? 6. You have to select one. 61 by 11 C1. So what is our first observations? Sum of these two must be 1. Yes, this is verified. Up to this is, if it is board problem, only half marks problem. So this is up to this step, half marks. Now, after transferring one ball from 1 to 2, a ball is drawn from second bag. You have to find probability of drawing black balls. So B equals to event of drawing black ball. One black ball from two after transferring one ball from bag 1. So here total ball will be 4 plus 3 plus 1. This is 8. Out of 8 you have to take one ball. So now it is B by E1. Probability of black ball from bag 2 when white ball is transferred. So this step is important. White ball is transferred. So white ball, one white ball is increased. So 5 white and 3 black same. But you have to find B by E1. From this you have to take one black ball. So how many black ball? 3, and total ball is 8. This is 3 by 8. This to be noted. So B by E1, probability of drawing black ball from bag 2 when white ball is transferred. So white ball transferred, so 5, and this is unchanged, but you are taking black ball. So this is 3 by 8. Now B by E2. So if probability of drawing black ball when black ball is transferred. So in this case it will be 4 white and 4 black. Because black ball is transferred, these 3 will be 4. Now this is 4 by 8. Because, this is 3 plus 1, this is 4 by 8. So this to be noted. So this step. Now last step. You have to calculate PB. So PB, PE1 into PB by E1 plus PE2 into PB by E2. So this is plus this total probability. So 5 by 11 into 3 by 8 plus 6 by 11 into 4 by 8. So 88 LCM. 88. 15 plus 24. So this is 9 and this is 39. 39 by 88. 39 by 88. So this is final answer. So this type of problem, look, this B by E1, 3 by 8, B by E2, 4 by 8. Because, look, probability of drawing black ball when white ball is transferred. Black ball when black ball is transferred. So this step to be noted. So this is second type problem. Now we consider one more problem. Here data are given directly. So in a bolt factory, 3 machines A, B and C manufacture 25%, 35% and 40% of the total bolts of their output. Full stop. Of their output, 5%, 4% and 2% are respectively defective. A bolt is drawn at random from the product. What is the probability that bolt drawn is defective? So there are 3 machines A, B and C. So E1 equals to event. So event that bolts are produced, manufactured by from machine 1, E2 from machine B, sorry, this is not, and E3, this is machine C. So they are not manufacturing equal number of products. That is why PE1 equals to PE2 equals to PE3, not equals to 1 by 3. So they are not producing equal number of products. So PE1, it is given directly 25 by 100. PE2, 35 by 100. And PE3, so 40 by 100. So what is our first observation? 60, 40, 100. So 100 by 100, 1. Sum of probability is 1. So therefore they are mutually exclusive and exhaustive. A bolt is drawn at random from products. What is the probability that bolt drawn is defective? So D equals to event that bolt drawn is defective. So P D by E1, defective bolts from machine A. It is given directly. This is 5%. So 5 by 100. P D by E2. So given directly 4 by 100. P D by E3. 2 by 100. So values are given directly. So it is very, very simple. So now you have to find PD. PD. So this is PE1. You must write this step for both of them. PE2. Defective bolts from machine E2. Defective bolts from machine C. So D by E3. So you are taking total. That is why it is total probability. So 25 by 100 into 5 by 100. 35 by 100 into 4 by 100. So 40 by 100 into 2 by 100. So simplifying, so this is LCM. 1 to 5 plus 140 plus 80. So 205 and 140. So 345 by 1. So this is final answer. So for this type of problem, so probabilities are given directly. So this is very, very simple problem. So through this video, I have discussed theorem of total probability and its applications. So these problems are important for both. So using theorem of total probability, we solve in next class Bayes theorem. So thank you for today.